Okay, so on to question 5. What is the product of the reaction below? Draw all hydrogen atoms. Okay, so let's draw out the reactant. So we have a 4-carbon chain with a double bond at the end, and it is added with chlorine. Okay, so I'm going to draw out a mechanism that may occur. So this double bond will come and attack one of the chlorines, kicking off the second one. And we have an intermediate. That now has a single bond and a newly attached chlorine atom where the double bond used to be. And then this leaves us with this positively charged carbon. But then one of the chlorines that was formed in the previous step that now has a negative charge will come and neutralize that positively charged carbon, which gives us our final product. So now there are 2 chlorines where the double bond used to be. And if we were to name this, I like to first find out my parent chain, which is the longest carbon chain that contains all of the most important substituents. And then from there, you would number the carbons, and we want the least number possible. So I'm going to start numbering where our chlorines are. Okay, so again, we have that 4-carbon chain. And then to show which carbons the chlorines are on, it would just be carbon 1, carbon 2. And then to show that there are 2 chlorines, we would use the prefix di. And then chloro. And then our parent chain is 4 carbons, so it is butane. Okay, so let's see what the junior tutor said. The given reaction above is an addition reaction of an alkene. In our example, the alkene is 1-butene, and the electrophile to be added is Cl2. Since Cl2 has 2 chlorine atoms which are alike, we do not need to think about Markovnikov's rule. The reaction mechanism will be as follows. Okay, so they have the same kind of mechanism. First, an instantaneous polarity will be affected on the Cl2 molecule, where one chlorine would be the partial positive center and the other the partial negative center. Then the pi bond of propylene will attack the partial positive chlorine, and then the chlorine-chlorine bond would break, which would result to a carbocation of 1 butene and a chlorine anion. Yep, so that's what they got here. And then the chlorine anion is and the formed carbocation. So carbocation, or it's just another word to say a positively charged carbon ion. So this will react to form the new molecule, a dichloral alkane. In our example, the alkane formed is 1,2-dichlorobutane, and the structure is shown below. Yep, so the solution is correct.